Hello, today's lesson is all about word problems. So last week we talked about how to develop a system of linear equations and how to solve them. Today we're going to take those tools and apply them to solving word problems. There's different types of word problems. The first one that we're going to start off with is interest type questions. So let's go ahead and read question number 1. Sam invested a total of $15,000. He put part of it in a term deposit that paid 4% per annum and the remainder in a treasury bill that paid 5% per annum. After 1 year, the total interest was $690. Algebraically determine the amount that Sam invested at each rate. So what this question is saying is that Sam invested a total of $15,000. He put a part of it in this account and he put another part of it in this account. The term deposit, the amount that he put in here, there was a 4% interest rate. And the amount that he put here, there was a 5% interest rate. And at the end of the year, he realized that he made $690 from the interest rates. And the question is saying, how much money did he put here and how much money did he put here? So the goal is to develop a system of linear equations. You can either go ahead and jump right into that, or you can draw a table. That way you can organize your work and your thoughts better. Okay, and throughout this whole lesson, you'll see me drawing tables, so you might want to kind of get in the habit of that. So what I've included in this table is kind of some key information that they gave us. So they talked about the total amount, okay? They also talked about interest, and they talked about 2 accounts. And the first thing that I'm going to go ahead and do, because I know I'm going to be talking about variables, because they're asking me how much money did they put in the term deposit and how much money did they put in the treasury bill. So I'm going to say that let X represent the term deposit, and we're going to let Y represent the treasury bill. Okay? And what we know is that he put X amount of dollars in the term deposit, he put Y amount of dollars in the treasury bill, and in total that's going to be $15,000. What we also know is that the amount of money that he put in the treasury bill, that was being multiplied by 4%. And so instead of putting 4%, I'm going to make that into a decimal, because remember 4% is 4 over 100, which is 0.04. And they also said that the amount of money that he put in the treasury bill, they got 5% per annum. So we're going to go ahead and go 0.05 and multiply it by the amount that he put in. And the interest that he made here and the interest that he made here, in total, he made $690. Now I can take my information that I got from this table and I can make them into a system of linear equations. So he put some amount in his term deposit, he put another amount in his treasury bill, and in total that was $15,000. So my first step is to go ahead and make a system of linear equations. My second step is to go ahead and solve this. So again, my goal is to solve for X and to solve for Y. And in this case, I'm going to go ahead and use the substitution method. So I'm going to substitute for X, okay, then plug it back into one of the equations, and then come out with 2 numbers. So if I'm looking at this equation over here, I can isolate for X or Y, it doesn't matter. So I'm going to subtract Y on both sides. So I'm going to have X equals 15,000 minus Y. I'm going to take that X and I'm going to plug it into this equation over here. So I'm going to go 0.04, and instead of X, I'm going to plug in 15,000 minus Y plus 0.05Y equals 690. Now, if you got to this point in the lesson and you understood it, that's amazing. To get from here to here, that was your other videos from last week. So you might want to brush up on that, okay? But again, to do substitution, you're going to isolate for one variable, then you're going to plug it back into the other equation, and now you only have one variable to solve for here. So my biggest mistake possibly is to, again, make sure that you're distributing that 0.04 inside the brackets. So expand that out. So I have 600 minus 0.04y plus 0.05y equals 690. I'm going to go ahead and collect my like terms. So I'm going to add those y's. Plus 0.01y equals 690. So I'm just running out of space here, but y is going to equal to y equals 9,000. Now, if I know what y is, I can plug that back in to one of my equations or the other equation that I haven't used, and then find x. So I'm just running out of space, but we're going to make it work. Change my color. So we have x plus y equals 15,000. And instead of y, I'm going to plug in what I know and isolate for x. So x equals 6,000. So now my final answer is going to be Sam invested $6,000 in the term deposit, and he invested $9,000 in his treasury bill. So I can go ahead and I'm just going to erase this. You can always rewind the video. We want to make sure that we're writing word sentences, full sentences, because this is a word problem. So we're going to go Sam $6,000 I'm just going to go ahead and erase this for a second. 5%. So this would be my final answer. So let's go ahead and move on to question number 2. A store sells 2 types of lawn fertilizer. One type is 24% nitrogen, and the other type is 12% nitrogen. Determine the amount that is needed from each type in order to obtain 10 kilograms of fertilizer that is 21% nitrogen. So you might want to pause the video, try to fill in this table by yourself, and then see if you've come up with 2 linear equations, or keep watching. So again, a store sells 2 types of lawn fertilizer. Okay, so we have type 1 and we've got type 2. Type 1 has 24% nitrogen. So it has 0.24% nitrogen. And type 2 has 12% nitrogen. Okay, and it's telling us that they want to get to 10 kilograms of fertilizer. So we know that if you add type 1, we're going to go ahead and call this X. And I'm going to go ahead and call this Y. If you add type 1 and type 2, you should get 10 kilograms. So I don't need to add the kg just yet, but we should be able to get 10. And if this has if this type has 0.24, if this type has 24% of nitrogen, and this type has 12% of nitrogen, together we're trying to get to 21%. But the key here is that it's 21% of 10 kilograms. So what you're actually going to do, so it's not actually, you don't go 21 here or 0.21. What you actually do is you go 10 times 0.21. This is 21% of 10 kilograms. So what you're actually going to get is you're going to get 2.1. Okay, so don't make the mistake of just including 21 here or 0.21. You really do want to make sure that you're understanding that it's 21% of the 10 kilograms. Okay, so now we've filled out our table. Now we're going to see if we've actually come up with system of linear equations. So I'm just going to change my color here. So my first equation is going to be x plus y equals 10. My second equation is going to be 0.24x plus 0.12y equals 2.1. Now at this stage, again, today's lesson is pretty much trying to get to here. If you can get to here, then that's great. Now to solve this, you can do it in any way that you want. I'm still going to use the substitution method, but if you wanted to graph it, you can. But it's totally up to you. It just depends on what the question is asking. And in this case, it doesn't tell me what they want. So I've come up with my system of linear equations, which is perfect. Now I'm going to go ahead and do the substitution method. Like I said earlier, if you do not know how to solve a system of linear equations, that's going to be your first priority. Okay, so my first step is to go ahead and isolate for one variable. In this case, I'm going to isolate for y. We'll get to the same answer we'll get to the same answer regardless. So I'm going to go ahead and go y equals 10 minus x. Now I'm going to plug in y into this equation. So I'm going to go ahead and just erase this. That's the beauty of videos. So I'm going to go ahead and plug it in back here. So I have 0.24x plus 0.12. Instead of y, I'm going to plug in 10 minus x equals 2.1. Again, I'll use red. Red just signifies just the common mistakes. So now I have 0.24x plus 1.2 minus 0.12x equals 2.1. I'm going to go ahead and collect my like terms. So I've got 0.12x plus 1.2. I'm going to subtract 1.2 on both sides. And I'm going to get so I found one solution. I now know that x equals 7.5. Now how do I find y? Well, I can just go back here or back to my original equation. So I can go back to my original equation and plug in x. So I'm going to go x plus y equals 10. Instead of x, I'm going to put 7.5 plus y equals 10. y equals 2.5. So again, it is a word problem, so you want to make sure that you include a sentence. I did erase that table that told me what x was, but I know that x was type 1 and y was type 2. So I'm going to go ahead and write a sentence. I'm going to say that they need, and I'm going to not forget my units. They need 7.5 kilograms of the 24% nitrogen, and 2.5 kilograms of the 12% nitrogen. And that's it. Question number 3 is a different type of question. It is a distance, speed, and time question. So before we move forward, what we need to recognize is one formula, and the formula is distance equals speed multiplied by time. Okay, so you want to have this formula memorized. What you also want to recognize is that I can manipulate this formula to find time, because if I just divide both sides by s, then I'll find my formula for time. And let's say I wanted to find speed, I can just divide time on both sides and isolate for that variable. Okay, but in this case, I don't need to memorize these two formulas. I'll just need to memorize this because I now know how to manipulate formulas and isolate variables. So moving on to question number 3. It took a patrol boat 5 hours to travel 60 kilometers up a river against the current and 3 hours for the return trip with the current. Now that makes sense because if you're going up a river against the current, it's obviously going to take you longer. So it's going to take you 5 hours. But let's say you're going down with the current, then it's going to take you 3 hours. And the question is saying find the speed of the boat in still water and the speed of the current. So what I've done is I've just written two variables to represent this. So I've went ahead and I said B is going to be the speed of the boat in still water, and C is going to represent the speed of the current. And I have my table over here that we've been practicing making. So I have up the river and I have down the river, and we're talking about distance, speed, and time. So let's go ahead and try to fill this out. So my distance is in kilometers. My time is in hours. Okay. And what I'm going to go ahead and try to fill this out. So up the river, it's telling me that they traveled 60 kilometers up a river, and it took them 5 hours. And going down the river, it was 60 kilometers down the river, but it took them 3 hours. Now the speed, and that's what our focus of this question is, I'm going to go ahead and use my two variables. So my speed is going to be, I'm going to look at the speed of the boat in still water, and when it's going up the river, the current is going to negatively affect that, because your speed is going to decrease when you're going up the river against the current. And your speed, the speed of the boat, is going to increase when you're going with the current. Okay, so I have B minus C and I have B plus C. Now with all the other tables, we were able to kind of see what our what our equation was. In this case, it's not too easy to tell, but we're going to go back to distance equals speed multiplied by time. So all I need to do is I need to look back and go, okay, distance equals speed multiplied by time. So I'm going to go ahead and go 60 equals, and I'm going to go ahead and multiply these two together. And same idea for the next one. Now I have my system of linear equations. I can rewrite this. Okay, so one way of doing this is going ahead and expanding your brackets. Okay, another way of doing this is just recognizing that if you divided 5 on both sides, okay, you would get 12 equals b minus c. And again, if I divided 3 on both sides of the, and again, I'm dividing this whole thing. If I divide 3 on both sides, then I'm going to get 20 equals b plus c. Okay? But it doesn't matter. You can go ahead. You can expand your brackets. You could do it that way. This is just a little shortcut. Okay? And it's kind of nice to just see. Now I have my systems of linear equations. So I'm going to go ahead and solve this. Again, you can solve this however you want, but it's kind of in a nice way that we can go ahead and just do process of elimination. So what I'm going to go ahead and do is I'm going to add both equations, and you'll see why in a second. So if I go 12 plus 20, I'm going to get 32. B plus B is 2b. Negative 1c plus positive c is actually 0. So now I'm left with this. And that's why you do process of elimination. That way you can eliminate one of the variables. So I'm going to go ahead and divide b on both sides. Oh, sorry. I'm going to divide 2 on both sides. And I'm going to be left with b equals 16. Okay, now I have one variable, so I'm going to go ahead and plug it back into one of my equations. So I'm just going to use a different color to represent that. So I'm going to go, it doesn't matter what equation I put it back into, but I'm going to go ahead and go 12 equals 16 minus c. I'm just using this equation. I'm going to subtract 16 on both sides. Negative 4 equals negative c, so I'm going to divide by negative 1. So I'll be left with, it's getting a little messy, but that's okay. Four equals c, or c equals 4. Okay, and so I now have my two variables. I have b equals 16 and I have c equals 4. Going back to my question, I said that b equaled the speed of the boat in still water and c equaled the speed of the current. So I'm going to go ahead and just write this in a full sentence. So I can go ahead, I'm just going to erase this. And my final answer is going to be so the biggest thing here is your units. So you want to make sure that you're writing kilometers per hour, okay? Because that's your unit for speed. And that's it. So question number 4, so the last question for this lesson. A truck leaves the city and travels at 95 kilometers an hour. 1 hour later, a car leaves the city and travels the same highway at 120 kilometers an hour. Determine the distance the vehicles have traveled when they meet on the highway and how long each vehicle has been traveling for. Okay, so again, you can pause this video and try to fill out this table. So let's talk about the truck. So it says that the truck leaves the city and travels at 95 kilometers an hour. So when I see kilometers per hour, I know that they're talking about speed. Okay, so the truck traveled 95 kilometers an hour, and it says that the car traveled 120 kilometers an hour. The question also says that it's the same highway, meaning the distance is going to be the same. Okay, I'm going to use red. So the time, this is a little bit of a tricky one. It says that 1 hour later, the car leaves the city. Okay, so 1 hour later, the car leaves the city. So which one had more time? Was it the truck that had more time or the car? The truck had more time. It had an hour of more time. Okay, so again, the time for the truck is going to be larger by an hour. Now, I'm going to go ahead and remember that there was this formula that I was supposed to use, distance equals speed multiplied by time, and I'm going to write this out as two different equations. So distance, so d in this case, equals speed, which is 95, multiplied by time. And then I have distance equals 120 multiplied by t. Okay, using red again to let you know that this is super important. You're going to go ahead and expand these brackets. So your two linear equations are going to be d equals 95, t plus 95, and d equals 120t. Okay, so these are my two systems of linear equations. Now, what you also want to recognize is, does this make sense? You have this extra, because it says that the truck traveled 95 kilometers an hour. So that's exactly why I have this extra 95 just sitting there, because they had an hour more. And in this case, it's super nice because I don't need to isolate for one of the variables because they're already isolated for me. D equals 120t or D equals 95t plus 95. So I can take either one and I can just substitute it back in. Okay, so what I'm going to go ahead and do is just go 120t. So instead of distance, I'm going to plug in 120t equals 95t plus 95. So in this case, I'm just making the equations equal themselves. Again, another way of viewing it is that I'm taking this distance and I'm just plugging it in here. Okay, so I'm going to go ahead and solve the equation like we've been doing. So I'm going to subtract 95 on both sides. 95t, sorry, on both sides. I'm going to divide 25 on both sides to isolate for t. So in this case, time equals 3.8. Okay, but what was time again? Time was the time for the car. But what about the time for the truck? Well, I'm going to go back to my t plus 1, and instead of t, I'm going to plug in 3.8. So t plus 1 equals 4.8. Okay, so, and then the question asks again, it says, determine the distance the vehicle has been traveling. So I'm going to go back into my original equation. So I'm going to go back to this one because it's nice and easy. D equals 120t. And instead of t, I'm going to plug in what I know, which is t equals 3.8. So distance equals 456. So I have a bunch of these numbers. So I have distance equals 456. I have time equals 3.8, and I have time plus 1 equals 4.8. So let's go ahead and just write out a sentence here. So my final sentence is going to be, so the question said determine the distance of vehicles traveled. So the vehicles, the vehicles traveled 456 kilometers. And then it says, how long did each vehicle travel? So the truck car traveled 3.8 hours. So that's my final answer. Again, you could have solved the equation any way that you want, but substitution method was just there. So as long as you can come up with the systems of linear equations, then you'll be good to go. And if you have any questions, just make sure that you reach out to any of your teachers.